Hi friends, today we are going to learn a method for constructing a cycloid. A cycloid is a curve. Let me explain what this curve is. Imagine a wheel, a circular wheel, which is rolling on the ground. So this line 8 to 8 dash is the ground line. This wheel is rolling on the ground. Now if I consider any point on the circumference of this wheel, let us say point 8. So this point is going to travel along some kind of a curve. That curve is called as a cycloid, and we need to trace the path of any one point on the circumference of this wheel. Let's learn the method for tracing this path. Look at the construction that we've already done. The circle is initially drawn with whatever radius is given to you. Divide the circle into 8 equal parts, which means you'll have to draw 45-degree inclined lines, 7, 3 and 1, 5. And that will give you 8 equal parts made of that circle. Number these points as I have done. So this point is called 1, 2, 3 and so on till point 8 here. Now on the ground line, I've marked all these points. Let me tell you what we have done. Calculate the circumference of the circle, and with that length, circumference length, from point 8, mark a point called 8 dash. So 8 to 8 dash is the circumference length. The next step is, since we have divided the circle into 8 equal parts, or you can say 8 equal arcs, I now divide this length 8 to 8 dash also into the same number of equal parts, that is 8 parts. Now this method for dividing a line in 8 parts, we have done it in school geometry, but let me quickly just recap. From this point 8, draw an inclined line. You're free to take any angle you want here. And once you've drawn this line, starting from 8, start cutting arcs which are of equal radius. So starting from 8, I cut my first arc here. From this point, I cut the second arc. Again, what radius to take is your choice. Okay, but see to it that when you start cutting these arcs, first, second, third, fourth, fifth, sixth, seventh, and eighth, the eighth arc, it's better if it comes relatively close to 8 dash. Try to use your judgment in such a way that the 8th arc comes relatively close to this last point 8 dash. Finally, join this point, the 8th arc to 8 dash, and to this line go on making parallel lines through all these arcs that you have already cut. So when you go on making these parallel lines, you locate point 7 dash, 6 dash, 5 dash, 4 dash and so on. In short, this length 8 to 8 dash, which is equal to the circumference of the circle, is now divided in 8 equal parts. I'm sure everyone appreciates the point that each part on this straight line on the ground, each part now matches with one arc on this circle. We have divided the circumference into 8 equal parts. Again, this length being equal to 8 equal parts, it's equal to circumference, we have divided that also into 8 equal parts. Next, from all these points 1 dash, 2 dash, 3 dash and so on, draw vertical lines. Okay. Also, from these 8 points that we have already marked, 1, 2, 3, 4 on the circle, get all these horizontal lines going like this, horizontal lines. So in short, you would have 5 horizontal lines. One starting from 4, one horizontal line which will pass through 5 and 3. Then there's a center line, then the 7 and 1 line, and finally the ground line. So 5 horizontal lines. All these vertical lines that you're drawing from 1 dash, 2 dash and so on will intersect the center line, giving you points called C1, C2, C3 and so on. Now look at the way we have numbered these points. We have not just numbered these points randomly. As the wheel starts to roll, since the arc from 8 to 1, this length is equal to the straight line from 8 to 1 dash, I'm sure you understand that when the wheel rolls, definitely point 1 would touch 1 dash on the ground. Later, point 2 would touch 2 dash, point 3 would touch 3 dash, and that is the way the wheel will roll and move forward. Correct? Also, can you understand one more thing? When the point 1 touches 1 dash, at that instant, the center would not remain here, but the center would have advanced to position C1. Okay, so just imagine center moves to C1. At that very instant, point 1 would be now touching the ground at 1 dash. When the center reaches C2, point 2 on the wheel would have touched the ground at 2 dash. And the cycle continues. Okay, that's the way the whole motion would keep on happening. Okay, now if this part is clear to everyone, we can actually start with the next part, which involves tracing the path of a particular point. What we are going to do is this point called 8. Let us trace the path of point 8 for one entire turn of this wheel. And let's see how it goes. Imagine point C has reached C1. In other words, the wheel has completed 1/8 of its complete motion, 1/8 of a turn. Now, point 1 would have reached 1 dash. In other words, 1 would have reached the ground. Now, do you see, as the wheel rolls, point 8 is going to take up the position of 7. 7 would take up the position of 6. 6 would take the position of 5. So every point is going to advance in this clockwise direction by 1 step as the center goes 1 step forward. Hence, when 1 touches 1 dash on the ground, one thing we know for sure is point 8 would now be in the position where 7 originally was. But at the same time, the wheel has also advanced forward. Wheel is not stationary at one point. Hence, even though 8 has reached the position of 7, it is not exactly here. It has moved forward also because the wheel has gone in the forward direction. Now I need to know where exactly point 8 would have reached. We know that the center to point 8, this distance is the radius of the wheel, which is a fixed quantity. It is something which will never change. So even as the wheel rolls, the center from C to 8 is going to remain fixed. Also, we know that 8 has now reached the level of 7. When the center reaches C1, 8 would have reached this level. Hence, to locate the position of 8, what we do is, with the radius C to 8 and with C1 as center, cut an arc 1 level above, that is on the level of 7. I repeat, the radius taken is C to 8. With C1 as center, cut an arc on this line, the line passing through 7. When the center reaches C2, 8 would now have gone 1 step further, which means it would have gone to the level of 6, which means it has reached this middle level. From C2, cut an arc on this line, and this cycle continues. From C3, cut an arc 1 level above. From C4, cut an arc again 1 level above. Now here you would find that this arc should ideally go tangential, or in other words, it will be exactly above this point C4. Now from C5, the point 8 is going to start coming downwards. That is, point 8 has moved this way up till point 4, and now it's on its downward path, which means it has now come to the right of the center. For this half of the motion, it was to the left of the center. Now it has come to the right of the center, where 3 was originally. Hence, from C5, you would cut an arc on the right, but 1 level below. 1 level below this topmost level. From C6, you would have to cut the arc again 1 level below. That means on the center line. From C7, again 1 level below. From C8, the arc would actually cut exactly here. So these are the points that we have located. Now we need to join it. Let me take a different color. We need to join this curve, and let's see how it looks. The final curve would go somewhat like this. Passing through all these points. So that's the nature of the curve, and this curve is called a cycloid. Okay, we have traced the path of this point, which was originally on the ground. Can you see? It starts on the ground and finally ends on the ground. the curve is perfectly symmetrical. Okay, and that curve is called as the cycloid. Thank you so much for watching this video.